this. Like I said, the first three are going to give you decimals or fractions. So when you solve them, remember you're solving them just like normal. Distribute, combine like terms, get everything away from the variable, and you should end up with 9/5. I switched the order of these two so I would know how to graph this. So x is greater than or equal to 9/5. If I read this way, x is greater than or equal to 9/5, it's the same thing. But if I read it the opposite way, it gets confusing. So with this, you could have whatever number line you want. Mine has fractions. If yours doesn't have fractions, that's okay. If you had whole numbers or whatever you had, as long as you have a closed circle on or around 9/5 pointing to the right, you are good. I also have the interval notation here. 9/5 would be in a square bracket towards positive infinity and a parenthesis. Questions on that one?
Superman.
Yeah.
Okay, it looks exactly the same.
It's not the same way. I swear I changed it. I was shut down.
For number 2, same process, solve for the variable. In this case, we would have x is greater than -1/2. I again had fractions and whole numbers in my number line. If yours didn't look like that, that's okay. As long as you have something that shows you have an open circle at -1/2 and it's going towards the right. Any questions on those two? Number 3, it asks which of the values they gave you were in the solution set. So you need to solve this as normal. But when you solve this, you get x is greater than 1/3. So you're trying to figure out which of these numbers are greater than 1/3. 1 and 2.5 would work. 1/3 would not work because it's not equal to. If it says greater than or equal to, then that would also work. And then my number lines, just to kind of show my work or my thinking, I just made a random one with, I used my fractions to show that 1 and 2.5 are greater than 1/3. Questions on that one? This last one is a little different than the things we have seen, because as you start to solve this, depending on how exactly you solve it, you either got 0 is greater than 15 or like -7 is greater than 8. Either of those. Usually in an equation, when we get something like that, it's like no solution. But with an inequality, no solution wouldn't be the set. I don't think I mentioned this before, so let me say this now. So when we're finding the answer to an inequality, there are many solutions already. So like x is greater than 1/3, it's every number that could be greater than 1/3 is a solution to that inequality. So we wouldn't say no solution, we would just say that this statement is false, or this inequality is false, and that would be our answer. When we can make a solution set, those are true inequalities. Anything else would be a false inequality. Do you have any questions on that one? So last class we talked about how to solve multi-step inequalities. Today we're going to take that a step further. So you should have these notes on your desk, the ones that say compound inequality. Yes.
What's a compound inequality?
It is two or more inequalities joined together. With and or. So let's make sure you're paying attention. So when we deal with these compound inequalities, there are going to be two different types. One are going to be and inequalities. The other type are going to be or inequalities. So we're going to talk about how to solve both of them and graph both of them. Anyone still need this definition?
Let me ask you a question. Which is more, will there be more people? And I have friends that play pickleball or bicycle. You got that? I have friends who play pickleball or bicycle. Is that going to have more or less people than this statement? I have friends that play pickleball and bicycle. Which one has?
Wait, say it again? Because I think I know which one it is, but I just want to.
Okay, sure, good. I have friends who play pickleball or they bicycle. And then I have friends who play pickleball and they bicycle.
Okay, and then what was the question again?
Which one has more people in it?
Second one.
Second one?
Yeah.
Everybody agree with Josh or go down and plans with Josh?
Bro, come on.
The and, right? You gotta have both. I mean,
I really do
play
this.
pickleball or bike, you got a lot more.
I really do.
Anyway, here you go you're on the math one.
I was right?
No, you went down and playing. You went down like Batman did, without he missed.
Yeah, Batman did. Yeah, he went down.
All right, you're a Spider-Man guy. I'm a Spider-Man. He missed his rope and he crashed on the ground.
Ooh. How do you miss the rope? He throws it out of his hand.
We're not.
Wow, that doesn't make sense. How do you miss somebody like something that came out your hand?
I guess it just didn't fit.
Somebody burned it.
Yeah, somebody touched something.
You got like a you didn't aim or anything. Anyways, let's refocus.
Everybody gets clapped against me.
Okay. Or inequalities have a tendency to graph apart. You'll see what I mean here in a second. So if we were to solve our inequalities and we get these two answers, x is less than or equal to -2 or x is greater than 3. We're going to draw both of these on our number line. Some of you are on your phones and you should be paying attention. So this would be a closed circle at -2. Going to the left.
Those are my pickleball players.
And then this one would be an open circle at 3. Going to the right. So when we write this in interval notation, we're still looking left to right, furthest left to furthest right. So furthest left, this is going to keep going towards negative infinity. So that's where we're going to start. And it goes from negative infinity and stops at -2. And it's included, so you need a square bracket. Or, the word or. It starts again at +3, but it's not included, so you need a parenthesis. And then it keeps going towards positive infinity forever and beyond. don't recall if I mentioned this or not, but when you write this, you can either write these as the solution set, or you can write them as the interval notation. When it comes to like the review, the quiz, the test. On this, practice both, so you get good practice on using both.
Is the first number you write bigger or smaller? Or
Both.
both?
What?
Yeah.
The first number you write is bigger or smaller, you get both?
Yeah.
Alright.
Smaller.
Sounds like Batman and Spider-Man are the same.
Sounds like they're the same?
You're not getting to that.
Yeah, they're not. One is a billionaire, the other one
Anyway,
goes.
One's a human, the other one's a human.
Maddie, what was your question?
When would you put the parentheses in the brackets?
Parenthesis is for open circles or strictly greater than or less than. Square bracket is for closed circles or. Now we're going to actually solve one of these and then bracket and do all of those things. So for number 1, you have 2 different inequalities. Solve them separately. What I mean by that is what you do to one, you are not doing to the other. You are solving them as 2 separate inequalities. So for this one, we would add 4 to both sides. That would give us x is less than negative 3. Then we would bring down our or and do the other side. On this inequality, I just need to divide both sides by 2. So that would give me x is greater than or equal to 6. So now we have 2 separate inequalities in our solution set that we can draw on our number line. This one would be an open circle at negative 3, going to the left. This one would be a closed circle at 6, going to the right. What I don't want you to do, though, is assume that the right inequality is automatically going to go right, and the left inequality is automatically going to go left, because you could switch them, you could divide by a negative, and the sign changes direction.
Didn't we say that if we divided them, the sign switched?
Yes. Did we divide by a negative?
Oh, it's by a negative. No,
Right.
okay.
Right. Only when you divide by a negative.
I was just making sure.
So this would be our solution set. And then we could write this in interval notation. It's going to start at negative infinity and go to negative 1. I'm sorry, negative 3. I drew that incorrectly. That should be right here. It is an open circle, so it is not included. So you should have a parenthesis. The word or. And then it starts again at 6. It is included and goes all the way to positive infinity. Do you have any questions on how we solve that, how we graph that, with the interval notation? less than usually points to the left. So x is less than -3 would be everything below. X greater than usually points to the right. So x is greater than or equal to 6 would be everything above. Yes.
This is about the sense, right? So, the one above you put the bracket at the end, but then this one you put it.
Yeah. So this one had a closed circle. So closed and square bracket go together. Open circle and parentheses go together. But the negative and positive infinity always has parentheses.
So,
I have a question.
Hold on.
oh, so if the closed circle is before in the bracket?
It doesn't matter where it is. If it was here, it would be a bracket. If it was here, it would be a bracket. If it's a closed circle, this number
Where it
would
is.
be.
Okay.
Josh, what's your question?
So I already did number 2. Do you want me to wait till you do it, or can I ask you a question?
That's going to be one of your practice problems, so hold on.
Okay. I also have a question.
So that's going to be one of your practice problems, so hold on. We're going to jump to number 3. And this might answer both Peter's questions. So again, you have 2 separate inequalities, solve them separately. You could solve one completely and then the other, or you could start to solve this one, start to solve this one, but you're doing separate things. So this one we would subtract 9 on both sides. And divide both sides by 2. And then we could solve the other one. Bring down the or. Subtract 10 on both sides. And divide both sides by 5. So this is a good example where the right side has a left equation and the left side has a right equation. If you wanted to, you could rewrite this as x is less than 0 or x is greater than 4. That way you know which one is left and right. But this would be our solution set. And we could graph that. X is less than 0 would be an open circle going to the left. X is greater than 4 would be an open circle going to the right. The interval notation for that one would start at negative infinity, go to 0, but it's not included, so we need parentheses. Or start at 4, but we need parentheses, and go to positive infinity. Yes, here.
Would those be close circles?
No, because these aren't equal to. If they were, then yes. Any other questions, concerns, confusion on that one? We're going to do one more of these together, and then I'm going to let you guys practice. Anyone still need this one? We're going to do number 5. For number 5, for this side, you could either divide both sides by -3, since 3 goes into 15 evenly, or you could do what we've been doing and distribute to solve it. Either or, you'll get the same answer either way. I'm going to go ahead and distribute, but if you divide, you'll end up with the same answer. And then we could add 3 to both sides. And divide both sides by -6. Here, because we're dividing by a negative, our sign is going to change direction. And then we could solve the other side. Bring down your or. On this side, we would be subtracting 1 on both sides. And dividing everything by -1. So again, our sign is going to change direction. Here's one.
Wait.
So right now they switch directions, so if you want to rewrite them, you could. X is less than or equal to -4, or X is greater than 2. That way you know which one's left, which one's right. So X is less than or equal to -4 would be a closed circle going to the left. X is greater than 2 would be an open circle to the right. And then the interval notation, it would start at -infinity, go to -4 and stop. It's included, so that would be a square bracket. Or start at 2, but it's not included, and go to +infinity. Questions, concerns, any confusion on that one? I'm going to give you the next 5 to 10 minutes to do numbers 2 and 4, and then we'll come back and we'll talk about them. Let us know if you have any questions as you're working through them, and you have this time to work. Answers to number 2 and 4 are on the board. You can check yourself. It's not showing all the steps, but number 2, they divided both sides by -3, so the sign flipped. This one, they subtracted 5 on both sides, and then they just rearranged it. So X is less than 1, or X is greater than or equal to 3. So there will be an open circle and then a closed circle, -infinity to 1 with a parenthesis, or 3 with a bracket to infinity. And then 4, when they solved that one, they added 14 to both sides and then divided by 7. On this side, they subtracted by 5 and divided both sides by 4. So X is less than or equal to -2, or X is greater than or equal to 2, so these should both be be filled in. When we do the interval notation, they should both be square brackets. Caleb and Preston, go back to your seats.
I would ask you, like, what was the point? You did not have a trophy.
Do we have any questions on those two?
No.
We're now going to move on to and inequalities. Basically, and inequalities is are the opposite of everything we deserve. So, or inequalities have a tendency to graph apart, and inequalities have a tendency to graph together. So for this, if we have some x's greater than or equal to negative 6, and x is less than or equal to 1, I'm going to graph this a couple different ways. One is with the arrows. Hi. Get to, nah, get to class.
That's why it's never a class. You see that? You see what I mean?
Hush.
Never a class.
So we're going to graph both of these where the arrows are, but then I'm going to show you how the final answer should be. So for this, if I graph this, x is greater than or equal to negative 6 would be a closed circle at negative 6 going to the right. The second one, x is less than or equal to 1, would be a closed circle at 1 going to the left. Because these are and inequalities, we're looking for where they both overlap or where both of them apply. Sure. And that would really just be from here to this point and everything in the middle. You're like third in line. Well, I'm going to write your pass down. That way we can try and speed this line up a little bit.
That's my pickleball players and cyclists, smaller group. People that play pickleball and cycle are in that middle group.
Oh, okay. I understand the question I asked in the beginning. Or it's like either they play this one or they play the other, and is they play this one and like this one. You know what I mean? Yeah, I understand what
They
you're
play
saying.
both, yes.
That smaller group of people.
You see, I'm smart. It just takes me a little bit.
So when we write this interval notation, it's going to be from the starting point to the end point. So that would be from negative 6 to 1. So the or inequalities graph apart, and they usually go towards positive and negative infinity. And inequalities graph together, and we're just focused on where they overlap. So they usually start and end. They don't go to positive and negative infinity. Before we move on to the next part, do we have questions on that part?
Josh, I got a new question for you.
Hit me with it.
For a quarter of a candy bar.
Hit me with it.
Somebody you either like apples
Okay.
or you like bananas. Okay, ready? That's one question. The next question is you like apples. You have to like apples and bananas. Which group has fewer people?
Okay. Ask the question. Hold on. Ask the question one more time.
You either a person either likes just apples,
Okay.
or they like just bananas,
Okay.
and then there are people who like both.
Which one has more people?
Which is
The or one.
which has fewer people.
Here, the and one.
You get a quarter of a candy bar.
Okay.
You got to school.
You see, you got what a full candy bar. A full candy bar.
Take a bite.
Come on now. Okay. I really do this on the weekend. Only on the weekend.
Today's Thursday.
You said inform us or you have to.
There's like 4 people in front of me. Okay, so for this next part, because the solution to and inequality fall between 2 endpoints, they're frequently written in a more condensed form. So instead of, and I just copied this example down, instead of writing x is greater than or equal to -6 and x is less than or equal to 1, I'm going to condense them and say -6 is less than or equal to x, which is less than or equal to 1. So when we write our answers, they're going to look like that. I should say like this or like this in interval notation. One of those two.
What?
Are you confused about something?
Huh?
Are you confused about something?
No, like I understand it.
Really?
Like I understand it, but it's like, so basically what you did is you put the x in the middle. Hold on. So this one stayed as it was, right? And for this one, you just put the 6 over here, move this, and kept the line, right?
Not quite. I'm going to show exactly what it is. Okay, so because it's going from this point to this point, it has to be everything from here to here and everything in between. If I read this part this way, x is greater than or equal to -6 is the same thing as this one. It just looks the opposite way. So read it right to left, and it says the same thing.
Yeah, so what I said was right.
I was just explaining it for the entire class.
Got it.
Any questions on that part before we actually solve these? Let's start at number 6. So OR inequalities were 2 separate inequalities that we graphed apart. That we solved separately and graphed apart. And inequalities are 1 condensed inequality that we need to solve all together. That means what we do to one part, we are doing to everything in the inequality. So for this, I would need to solve this by subtracting. So I would subtract 4 here, and then I'm going to do that on this side, to the right, and to the left. We're doing everything, we're applying this to everything. So that means this would become -2 is less than or equal to x, which is less than 5.
Wait, so we're not just doing.
So like what we were doing for OR, we are not doing here. We are applying this to everything. We're not solving them separately. Did that answer your question, Garrett?
Yeah.
Okay. So when I graph this, I'm going to start at -2. I'm going to have a closed circle there. Then I'm going to go to 5 and have a closed circle there. An open circle there. And I'm going to connect the dots. That would be your final answer. What I need to see is your final answer. However, if you're not sure exactly where the overlap would happen, or if you're not sure exactly how to graph it, you could go back and kind of separate this in your mind. Read this part right to left. X is greater than or equal to -2. So I would have a closed circle going to the right. Even though this is pointing left, I'm reading it as it's greater than points to the right. And then read this part as normal. X is less than 5. So I would have an open circle there going to the left. And you can see where these overlap. So from there to there would be your solution area. Drawing the arrows is not necessary, but if it helps you, definitely do that. Interval notation would be where does this start to where does this end? So it starts at -2, and it is closed, and it goes to 5, and that is open. What questions, concerns, or any confusion do we have on how we solve that, graph that, or did the interval notation? Let's do a couple more. I'm going to jump down and do number 9. So number 9 is solved very similarly, but there's a fraction, so it's a little different. What do you think would be our first step in 9?
Plus 1.
No?
Or minus 1.
Yes, minus. To all of the pieces, subtract 1 everywhere. We have -2 is less than 2 over 3x is less than or equal to 4. We would then need to get rid of the 2/3.
But wouldn't you add the 2 to the other side?
Which 2 are you talking about? In the
negative
fraction?
2?
Because that's on the other side of the inequality. So we just need to get everything away from x. So because this is a fraction, did you actually get the fraction? I know you did. Okay. Well, 221. We would multiply each side by this fraction flip, so the reciprocal. So if I multiply this by 3 over 2, I need to do that to each part. So that would become, this is -6 over 2, which is -3, is less than x, because these would just cancel, become 1. Less than or equal to 4 times 3 is 12. 12 divided by 2 is 6. So I could graph this. -3 is open. 6 is closed. And I could connect the line between this. If you wanted to see exactly where they overlap, you could redraw this. X is greater than -3, if I'm reading right to left, would be, an open circle to the right. X is less than or equal to 6 would be a closed circle to the left. And we can see where they overlap. The interval notation for that one would start at -3 and is open, and would end at 6, but is closed. Do we have any questions, concerns, confusion about that one? Yes, Gary?
You just do 4 times 3.
4 times 3, yeah, because this is really over 1. You're doing 4 times 3, 1 times 2, and then simplifying it. Last one that we're going to do together, then I'll let you try some. This one we're going to do 2 different ways. You really only need to be able to do one of them. It doesn't matter which one. One of them, because I see that this 2 goes into 4 and -2, I'm going to divide each piece by 2. So if this didn't evenly divide into both of these, I probably wouldn't do it this way. Or if it didn't evenly divide into one or the other, I wouldn't do it this way. So this would give me -1 is less than x minus 6, which is less than or equal to 2.
Maybe that's the only one.
And then we could add 6 on both sides. To get 5 is less than x, which is less than or equal to 8. Before I actually graph that, I'm going to go back and solve it the second way, or how you may solve it, and that's by distributing. You don't have to write this method down, but if you want it written down, you're more than welcome to do so. So in this example, you would just distribute in the middle, nowhere else. So the numbers on the outside would not change. And then we could solve this like we have been, add 12 to both sides. And then divide each side by 2. We end up getting the same thing that we did earlier. 5 is less than x, which is less than or equal to 8. So that shows you that no matter how you solve it, you should get the same answer as long as you do the math correctly. Now, let's say that this was a different problem, and this was a -2 on the inside. If I were to divide everything by a -2, all of the signs would change direction. But -5 is greater than x, which is greater than or equal to -8, is not usually written that way. It's usually written with the less than. So what you would do is just switch it back, but switch these two. Because -8 is less than -5, so you would say -8 is less than or equal to x, which is less than -5. You would basically take this entire thing and flip it around. This would be the answer you see. This would be the one you probably solved and got. But that's a hypothetical situation. Really quickly, because I didn't graph this, this would be an open circle at 5. And a closed circle at 8. And draw a line in between them. It's really short. Sometimes it's just a unit apart, and that's better sometimes. The interval notation would be from 5 to 8, open and then close. Do we have any questions about that? I want you to try examples 7 and 8. And then we'll come back and talk about that in 5 to 10 minutes. Hold on 1 second. Work through those and then we'll come back. Here are the answers to number 7 and number 8. It doesn't show all the work, but for number 7, the first thing was adding 13 to both sides and then dividing everything by 7. So -2 is less than x, which is less than 3. So when you graph this, these should both be open circles with parentheses. Number 8, you needed to add 4 to each side and then divide all the sides by 3. to get negative 4 is less than or equal to x, which is less than or equal to 2. So when you graph them, they should both be closed circles with square brackets. Do we have questions on either of those? How do we feel about compound inequalities? Thumbs up, thumbs down, somewhere in the middle. Good, good. Thank you for letting me to answer. I know we don't have much time, but for the remainder of class, I want you working on one of these 3 things. There is a practice page in the back of these notes that has a bunch of different compound inequalities. Be careful because it doesn't like have a title header or anything that says these are or, these are and inequalities. So make sure you know which one it is. You can work through those, or you have one Khan Academy on compound inequalities due tomorrow night. You also have one Delta Math that is due by Monday on compound inequalities. So you have 3 different things you could be working on. For at least the next 5 minutes, work on one of those things. Hold it up.